So today we are going to look at trig differentiation. We are going to actually prove how the derivative of sine x is equal to cos x, and we are going to use the first principle, okay? And there are some theorems that we'd have to consider. So let's look at this. We have this, okay? And then the theorems we are going to look at is, if let's say we have limit of a function, maybe you have t approaching 0, all right? And then you have sine t over t, this is going to give you 1, okay? And then when you have limit of a function where here maybe give you some k as k approaching 0, all right? And then we have cos k minus 1 all over k, this will give you 0. And put my cos well. So that one will give you 0. So let's see, we are actually coming to use them. But here we are going to use the first derivative, first principle. So let's see, if I want to get the f on the x, using the first principle, we are going to do f of x plus h, right? Minus f of x all on h. So that is what is going to give you your derivative. But here the function is what? Sine x. So we are going to have, sorry, here it is what? Limit as h approaching 0. Alright? So let me rewrite here. Well, it's going to be what? The f dx is equal to. Alright. Okay. So let's see. We are having f of x to be equal to a sine x. So let me say limit as h approaching 0, right? And then we are having what? Sine of x plus h minus sine x, all right? All over h. We know that this is sine x, this is a function, and then this is what? Sine of x plus h, so this is it. But we know that from some trig identities, when we have, let's say, sine of a plus b, this should give you what? This should give you sine a cos b plus what? Cos a sine b. So from that, we can actually deduce here that we are having limit as h approaching 0, right? Of what? Sine x cos h minus, sorry, this is plus what? Cos, so this is sine x, right? So this is going to be cos x sine h, right? Minus sine, let's take this off, minus sine x all over h. Alright, so since we have this, what next? Let's rearrange this, okay? So we have a limit as h approaching 0 of what? Cos x sine h, alright? Cos x sine h plus sine x cos h minus sine x, okay? All divided by h. Now, here we want to, let's simplify this. Let's make it limit as h approaches 0 of cos x sine h, alright, all over h, plus limit as h approaching 0 of, let me say, yes, of sine x cos h minus sine x all over h. Okay, now from this we can see that we can actually factor out here cos x so that we can get something similar to the first theorem. Have you seen it? So here let's factor out cos x. So we are having cos x, all right? Then this is going to be times limit as h approaching 0 of what? We are just going to be left with what? Sine h. And this is sine h over h. Plus, here too, let's see. Let's factor out sine x. If you factor out sine x, you are going to get, right? Factor out sine x, you are going to get what? Now we are having limit as h approaching 0. Let's take this line off for now. And then what are you going to have? We factor out what? Sine x. So it's left here with what? Cos h minus 1 all on h. Now mind you, this that we are having, this will give me 1. If this will give me 1, it means that I will be left with what? Only cos x. So let me redraw this line and then work in this corner. So if this will give me only cos x, it means that I'm getting cos x times 1. Because this guy here, I've now turned to what? Is equal to 1. So I've gotten 1. Now, let's look over here. Now this is plus this. Now, let's see. Cos h over h minus 1 is the same here. Okay? Just that the variable here is k. Alright? So it's just the same as cos k over k all minus 1. Okay? Cos k minus 1 all over h. So it's still the same thing here. So if that gives me 0, it means that I'm having sine x times 0. Alright? If that is so, now let's see. Here I factored out what? Cos x. Alright. Okay. So now we know that this is going to be what? Cos x plus here, because this is going to be 0, because this is 0 multiply the whole function, boils everything down to 0. So you have broken that whole function to 0. So it has no strength. So plus 0. So what are we now having? Our derivative, or which is what? Our df dx. Our df dx of that function of sine x is giving us what? Cos x. So as easy as that. So that is how can we got what? The derivative of what? Sine x is equal to cos x. Now if you do it otherwise, where you find the derivative of cos x, you are going to get a minus sine x. So that is an assignment. So find what? Okay, let me say the f of x is equal to cos x. Alright? If f of x is equal to cos x, now prove that the f dx, or yes, the f dx, we know that this f is equal to the f dx is equal to minus sine x. So let me see your solution in the comment box. Thank you.